In this video, we will discuss on applications of counting principles on probability. In fact, we'll discuss counting principles, we'll discuss applications of counting principles on probability, and we'll also discuss some previous year's question papers on probability. The question here is, consider the digits 1, 2, 3, 4, 5, 6, 7, 8 and answer the following questions. How many 2 digits can be formed if the repetition is allowed? So it's a 2 digit, that means I have 1 and 2 digits. Only 2 options I have, and a repetition is allowed. I have 8 choices. 1, 2, 3, 4, 5, 6, right? I have 8 choices. Therefore, number, right? So number of 2 digit numbers will be 8 times 8. 8 square is 64. Then 4, 1, 2. How many 4 digits can be formed if the repetition is not allowed? So I have a 4 digit, that means 1, 2, 3, 4 digits, and a repetition is not allowed. For the first digit on the left, I have 8 choices, and then we don't have a choice. The choice is limited now because it's not repeated. Therefore, I have 7 choices. And the following one, I will have 6 choices, and here I'll have 5 choices. Therefore, the number of 4 digit numbers, and this is non-repeating, will be 8 times 7 times 6 times 5, and you can use your calculator to find the answer. 1680. Next question here is 413. How many numbers between 4,000 and 5,000 can be formed? Between 4,000 and 5,000. Now let's look at here. How many? I have a 4-digit number, right? I have a 4-digit number, right? It's between 4,000 and 5,000. What I have choices for the first one? First one, I don't have any choice, but my first number should start with 4 only. I cannot start with 5. So only one choice. And the numbers can be repeated. That means I have, how many choices I have here? I have 8 choices, 8 choices, and 8 choices. Right? Because it is not mentioned whether the repetition is allowed or not allowed. Right? Then I'll assume that the repetition is allowed in the case of the numbers. So whenever there is not mention about this repetition or no repetition, we assume that it is going to be repeated. That is where my answer now here is number of numbers between, right? Number of numbers between 4,000 and 5,000 is going to be 1 times 8 times 8 times 8. So it is 8 cube. Cube is 512. That's my answer. So here, one important thing is when there's no mention is repeating or not repeating, we'll assume that it is going to be repeating. Next question. There are 7 different shirts and 4 different pairs of trousers in a cupboard. The clothes have to be hung on a rail. In how many different ways the clothes can be arranged on the rail? So the question is, how many different ways, right? So different ways, a number of different ways that I can arrange. So how many dresses I have in total? I have 7 plus 4. I have 11 dresses. Therefore, I can make them in 11 factorial ways. So that is my answer for the first one. Different methods, different ways I can arrange the dress, because I have 11 of them. So for my answer is 11 factorial. You can leave your answer as 11 factorial, or you can write as some 39, 916, 800 if you feel that is what is required. Or you can leave your answer as 11 factorial, or you can write 39,916,800. Next question 422. It says, in how many different ways can the clothes be arranged if all the shirts are to be hung next to each other and the pair of trousers are to be hung next to each other on the rail? That means shirts together and trousers together. In 4.2.1, they are need not be together. So now here it is, shirts are together and trousers are together. Therefore, shirts and trousers, right? There are two of them. So one is a shirt, and I have trousers, right? And within the shirt here, so for these two can be arranged in two factorial ways, right? They can be swapped. Therefore, I have two factorial ways of shirts and trousers. Now within the shirts, I have 7 of them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Therefore, there are 7 shirts, and I have to arrange them I can arrange them in 7 factorial ways. Similarly, for trousers, I have 4 trousers, right? I have 4 trousers. That means I can arrange them in 4 factorial ways, right? That's how I get this answer here. 2 factorial times 7 factorial times 4 factorial. Right? So 7 factorial for shirts, 4 factorial for trousers, and then the combination, right? I can swap them. First one is shirts, second one trousers, or trousers then shirts. So I have 2 factorial ways. So 2 factorial times 7 factorial times 4 factorial. You can leave your answer as it is, or you can use your calculator to find the answer. I mean, you can use your calculator to evaluate your answer. So I can write my answer as 2, 4, 1. You can use your calculator and see whether my answer is right or wrong. Now here we apply 4.2 the concept of probability. What is the probability that a pair of trousers will hang at the beginning of the rail and a shirt at the end of the rail? So what is the probability? So probability of any event, we know probability of an event, right? Probability of an event is a number of ways of favorable events, right? Number of ways of favorable event of happening A. Right? And the last one is total number, right? Total number of events, total number of possible outcomes or possible events. That is our basic definition of a probability of an event happening A. Now here, what is the event here? Event here is the beginning is a trouser. I am hanging them, right? And the first one is a trouser, and the last one is a shirt. So I have a rail here, and I have a rail, and the first one, right? First one. Remember, there are 11 of them, right? So if I draw them here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, the last one, right? First and the last one of the rail. My first one has to be a trouser, right? The first one, how many choices I have for the trouser? I don't have enough choice. My first choice, there are 4 choices for the trouser. It can be any one of them, right? My first choice, so I have 4 choices here. I have 4 choices here. What about the last one? Last one, there are 7 shirts. Therefore, I have option for 7. Right? Last one is I have 7 choices. I have 7 choices here. Now the rest of them we do not know. It can be shirt, it can be trouser, right? We do not know them here. Therefore, these can be arranged in 9 factorial ways. So I have 4 choices, right? For the 4 choices, and then 9 factorial, and the last one is 7. There are 7 choices for the shirt. So this is a probability of happening the event. That what is the event here? The beginning is a trouser. The beginning is a trouser, and the last one is a shirt. So this is a probability of. This is the number of events possible events. Now I have to calculate the probability. Therefore, the probability of the event here is 4 times 9 factorial times 7 divided by total possible outcomes. My total possible outcomes here is 11 factorial. Right? So my 11 factorial. So I can calculate this using my calculator now. You may either write as 28 over 110, or you can even round off to 2 decimal places. I think it's 0.33. So whichever that is convenient to you, you can write it. So this is where we apply the counting principle, the probability of finding the pair of trousers at the end and the shirt at the end. So here what I found here is I applied the basic concept of the probability, the definition of the probability, the possible favorable outcomes divided by total number of possible outcomes. Next question. Product. I have to consider this word P-R-O-D-C-U-T. So how many letters I have? P-R-O-D-U-C-T. 1, 2, 3, 4, 5, 6, 7. So I have 7 letters. How many different arrangements are possible if all the letters are used? So I have 7 letters. How many different arrangements I have? So number of different arrangements or different methods or different arrangements. So different arrangements will be 7 factorial, or you can use the box like this. I have 1, 2, 3, 4, 5, 6 and 7. The first 7, 6, 5, 4, 3, 2, 1. So you can use a 7 factorial, and you can use your calculator to evaluate 7 factorial. And I get as 5040. Please look at your you do your own calculations and verify the answer. Next question is 4.3.2. How many different arrangements can be made if the first letter is T and the fifth letter is C? Now what I'll do here is I'm again going to draw these 7 boxes and denoting 7 options, because there are 7 letters. Now first letter has to be T, so I have fixed it. I have no choice. Okay, and fifth letter, so 2, 3, 4, 5. Fifth letter is C. I don't have a choice. Right? Fifth letter has to be C. It's supposed to be written the other way around. Yeah. So here I have to write as C. Here my C is fixed. My C is fixed, and I don't have a choice. Therefore, there's one choice. So now what is remaining here? So remaining, how many there are? 5 of them. Therefore my answer is, so number of different arrangements with first letter T and last fifth letter C. Therefore I don't have a choice here. For T and C, therefore there is 1 times. So here I can write as figure 5, not repeating here. So it is 5, this is 4, this is 3, and this is 2, and this is 1. 1 times, 5 times, 4 times, 3 times, 1 times, 2 times, 1. So it's actually, in fact, it is 5 factorial, right? I guess 5 factorial. You can use your calculator to evaluate, or if you know it, is 5 factorial is 120. The next question here is 433. How many different arrangements can be made if the letters R, O, D must follow each other? Therefore, I have R, O, D, and they must be together always. They must be united. That means they must be tied as one number. So that is where we are going to do that now. So if I tie them R, O, D as one, right? Therefore, I have R, right, and I have O, and I have D, right? So they have to be tied. Those two, I must consider as one number, one letter, sorry. considers one letter. Therefore, remaining I will have how many letters? I will have 4 letters, right? Therefore, remaining letters, so 1, 2, 3, 4. Therefore, how many letters I have now? I have combined this as 1, right? Therefore, I have 5 factorial methods and then 3 factorial for this ROD. I can arrange them ROD in 3 factorial ways. Therefore, the number of possible arrangements is, so number of different arrangements is equal to 5 factorial times 3 factorial. So we must not assume there's going to be 4 factors, it's supposed to be 5 factorial because ROD is considered as a one letter, and then we consider them as rearranging them with the other letters. And if a total different arrangement is 5 factorial, but within ROD can be in any order, must follow each other, can be in any order. Therefore, that is given by 3 factorial ways. So that is my answer, 5 factorial times 3 factorial. Again, you can use a calculator to calculate, and that will give me 720. So number of different possible arrangements with ROD together is 720. Yes, a bank has a personal identity number, a PIN, made up of 5 digits chosen from the digits 0 to 9. 0 to 9 comprises of 10 digits, 0 to 9 including 0. There are 10 digits. From these 10 digits, I have to make a 5-digit PIN. So when I answer 5441, there are 5 digits. 5 digits. Now, digits can be repeated. That means my first digit is 0. I can be all 0, it can be all 8, or it can be 88, 99, 7. Yes, the digits can be repeated. Therefore, I have 10 choices, 10 choices, 10 choices, 10 choices, 10 choices. So, for number of pins repeating, right? So, number of possible pins is 10 to the power of 5. So, you can you don't have to use a calculator. Must be able to write as 100,000 because you're not using a calculator because 5 zeros. Then question number B. Digits can be repeated. So if I have a 5-digit number, that means if my first digit is 4, that means 4 cannot be repeated. If my number of choices is limited, so it is 10, then 9, then 8, then 7, then 6 remaining, right? Number of pins possible is 10 times, 9 times, 8 times, 7 times, 6. And you can use a calculator to evaluate that one, and it is 30,420 as the possible pins with this repeating. Let me write down these questions. No, there's one more question here. What is the question? Suppose a pin can be made by selecting digits at random, that the digits can be repeated. So digits can be, so option number 1. What is the probability such a pin will contain at least 1 9? I think I should believe my intuition. My intuition was to write these answers here. So let me write them here, because it is repeated if I don't want only that one. So and allow me to wipe the remaining of them. So what was it here? I will need a pin that contains at least a 9. Right? So as a probability, it contains a 9. That means 9 can be anywhere. There are 5 digits. So 9 can be first option, second. There are 2 methods to approach this problem. First, let me use the concept in probability. That probability of A complement is 1 minus probability of A. Okay, so what I do here is the probability of at least 1 9, right? Can be more than 1 9, it can be only 1 9, or it can be 2 9s, it can be 3 9, or all of the 5 9s, right? At least 1 9, that's the meaning. There should be at least one of them must be 9. So what I do here is, what is the probability having no 9? That's what I'm going to do now first. It does not contain a 99. what I'm going to do. That means no 9 means a complement of 9. That means that will give me probability of having a 9. Event 9. Don't think it's a probability. It's event 9. That's what I'm going to do here. Now, in other words, probability of no 9 is equal to 1 minus probability of at least 1 9. Okay, so probability of no 9 is equal to 1 minus probability of at least 1 9. That's what I am going to do here. No 9 means how many digits are available with me now. I have only 9 because I am removing 9. No 9, right? So no 9 means I am removing 9. Therefore, number of possible events is possible choices here is 9. Number of is repeating. Therefore, 9, 9, 9, 9. So number of possible no nines. Known without a 9 is 9 to the power of 5. Therefore, probability of no 9 is 9 to the power of 5 divided by 10 to the power of 5 or 100,000, whichever it is. So this is my probability of no 9. Now remember, the question is to find the probability of no 9, right? That means probability of at least 1 9 is equal to 1 minus 9 to the power of 5 divided by 10 to the power of 5 or 100,000. So this kind of questions can come as an exam question. I think it appeared in last year also, a similar question on using this property. A complement is equal to 1 minus probability of A. So what I do here is my no 9, right? So I calculate here no 9. That is using this then I calculate probability of at least 1 minus. So that is where I use this concept here, probability of complement. First I find the complement and then I find at least 1. So at least 1. Right, so it means the complement is no, it does not happen, and I can use my calculator to event and to calculate this probability, which is going to give me 0.41. So probability of having at least 1 9 is 0.41. Next question. Suppose a number plate, vehicle number plate, has 3 letters and excluding the vowels and Q. So how many letters are excluded? There are 5 vowels and 1 Q. Therefore, I exclude 6 letters for the letters from the number plate and followed by 3 digits. So how many digits I have? I have from 0 to 9. Calculate the probability the number chosen at random starts with B and ends with 5. The question now straight away is to probability. Right? So first I have to calculate the total possible outcomes, or in other words, I have to calculate this sample space. So what is my sample space here? There is a total possible outcomes. We want that because we have to calculate the probability. So I have a 3-digit alphabet number plate, vehicle number plate, and a 3-digit 3 spaces, 3 letters for alphabets and 3 digits. So how many alphabets I have? I have 20 alphabets, right, excluding the vowels and the Q. So from 26 I subtract 6 of them, therefore I have 20 possibilities, right? They are repeating. They can be, is not mentioned whether it can be repeated or not repeated, but since not mentioned, we'll assume that they are repeating. So 20 times 20 to the power of 3 is total sample space is 20 to the power of 3 times 10 to the power of 3. Since the question doesn't mention about total possible outcomes, I'm not evaluating and keeping it aside. for my calculations, further calculations. So let me put it aside here. Now the question here is starting with D, probability the number place chosen at random starts with D, starts with B, right? So here I have a 3 letters and I have 3 digits, and I'm going to start with B. My B is fixed and end is also 5, which is fixed. So here I don't have a choice because it's fixed, first letter and the last one, last digit is fixed. So what are the remaining one here? How many choices I have here? 20, because it can be repeated. I have 20 choices. What about here? Is 10 choices. I trust it's clear. So the probability the number plate starts with B and ends with 5 is 2. How many choices I have? 1 times 20 to the power of 2 times 10 to the power of 2 times 1 divided by total sample space is 20 cube, right, times 10 cube, the total sample space. So probability here, what I get here is I can evaluate using my calculator, or without even calculator you can say it is going to be 1 over 200. That is answer number A. Now B. What is it? Exactly 1B. Exactly 1B implies that I have 1B can be in the first place, right? It can be in the second place. It can be in the third place. We do not know where it is, but there has to be 1B, right? So B can come in any of these 3 places, right? It can come 1 here, can be second place, it can occupy the third place. Therefore the B can occupy in 3 places, therefore it is 3 times. I trust that is clear. Next it is exactly 1, therefore B cannot be exactly 1. That means B cannot, if I choose one of the first is my B, then I cannot choose second one, this cannot be B here. Therefore the number of choice has been restricted to 19. But that can be repeated. That means BAA is possible, right? Or BCC is possible. Or CBC is possible. DBB is possible. Sorry, DBD is possible. DDB is possible. Therefore, that choices I have here is restricted to 19 because I exactly 1, right? So it is 3 times, right? 3 times 19 squared. There's no restrictions in numbers in question number B, right? So it's 10 cube. Therefore, the probability of exactly 1B will be 3 times 19 square to the 10 cube divided by 20 cube. Right. Even if you evaluate this one as 20 cube times 10 cube is 8 million, which you can use that one also. So here my answer here is I can use my calculator. Definitely have to use a calculator here. So what I get here is 0,14 approximately. Approximately is rounding off to 2 decimal places. I get 0,14. Now next question here is exact as at least 1. Number C, as exact as at least 1 phi. So we are exactly 1 phi, right? So probability of at least 1, right? At least 1 phi, right? At least 1 phi can be as 1 minus probability of no phi. I use that one, probability of A is equal to 1 minus probability of A complement. So the at least is none. The complement of at least is none. Therefore I use that property here. So what I do here, I calculate without phi, without any phi. That's what I'm going to calculate. First one. So let's look at the scenario here. I have first 3 letters and then followed by 3 digits. Now it is say no phi. I know no phi. There's no phi, right? No phi. So choices for the letters is no restrictions, but no phi is restrictions now. That means my number of choices is limited. I cannot have a phi here. Therefore, number of choices is limited to 3. Sorry, number of choices is limited to 9. So now that is my choices for no phi, right? 9 to the power of 3. So now let's come to the answer here. So probability of at least one phi here. What I do here, 1 minus probability of no phi. I don't want any phi. So 1 minus what is it? Is it 20 to the power of 3 times 9 to the power of 3 divided by 20 cube times 10 cube. I assume you understand why I did not evaluate 20 cube times 10 cube for ease of calculations. So it is now, I can use my calculator now here. 1 minus 20 cube times 9 cube divided by 20 cube times 10 cube. And I get my answer as, how much I get the answer? Is equal to 0,271. If you want to write 1 also is fine. So to rounding off to 2 decimal places, I get my answer as 0,27. Yes, so that is my answer. So again, I again use the property of the property here, or the formula, probability of A is equal to 1 minus probability of A complement. Now, next question. So it's a typical exam type question now. So it's a mixture of all the concepts that we have learned in probability. What's the question here? Each passenger on a certain Banana Airways. I was wondering why there is no food and beverages in statistics. As at least one beverage from tea, coffee, or fruit juice. And the results are shown as below. Write down the value of A. So write down the value of A. So I just have to add them, right? So 80 plus 20 is 100. Therefore, my A is equal to 160. So I got it as 160. Next, what is the probability that a randomly selected passenger is a male? So probability of a male. So how many male I have? 60. So probability is 60 over 160. You can evaluate using your calculator. This is 60, not 66. So 60. So I get here 0,375, or you can write as 0,38. Next question. 10.1.3. What is the question here? Given that the event of passenger choosing a coffee is independent of being a male, calculate the value of B. It is given that the event passenger probability of choosing a coffee, right? C for coffee, and male, right? Male are independent. Independent means is given they're independent. That means I can write as probability of coffee times probability of male. They are independent. Therefore, probability of coffee, we do not know what's the probability of coffee. Probability of coffee is 80, right? 80 out of 100. So independent. So it is 80 over 160 probability of coffee. Also, probability of male is 60 times 160. Now, what is probability of male and coffee? Probability of male and coffee, you can see this is B, the A and, right? Common to coffee and male. Therefore, that is going to give me B over 160. All right. Now I can calculate B. So this is given that they are independent. This is given that they are independent. So if I can write like this, that I can use this product rule for independent events. So probability of coffee and male is equal to probability of coffee times probability of male. I can write this only when they are independent. So I can now calculate now. Now next is symbol calculations here. So it is 80 over 160 times 60 over 160 times 160. and that will give me b is equal to 30. So b is equal to 30 here. Now very interesting part is that we don't have to calculate B, T, C, E, right? It's not asked, it's not inquired by the examiner. Therefore, why we should not spend unnecessary time in calculating B, T, C, E, and we will not be able to do it unless we come to 10.1.3. So read the questions very carefully and try to answer the question that is required by the examiner. I find there's many of them and they try to calculate B, D, C, A and then proceed to 10.1.1. No, we can't calculate in fact these values. So try to calculate only those values which you feel that is necessary. Again, Banana Airways has 6 seats in a room. How many possible arrangements are there for 6 people to sit in 6 seats? Therefore, what is the possible arrangements here? So I think it's a very straightforward question. Number of possible arrangements. So 6 people can sit in 6 factorial ways. So you can use your calculator to find 6 factorial. I assume is going to give me I value is 720. Next, 10 to 2. Koliswa, Anis and 4 other passengers sit in a certain row on a Banana Airways. If in how many different ways can these 6 passengers can be seated if Kolisa and Anis must sit to each other? Therefore, these 2 people are sitting together. Right? We do not know in what order. Therefore, we will have 2 factorial ways for that one. And the remaining 4 of them, it can be in any manner. Right? Therefore, a total value I will have is 5 factorial ways. I consider them as this as 1. Therefore, they'll have 5 factorial ways. So, number of possible arrangements with Kulisa and Anis together, right? They have to be together. Therefore, that will give me 2 factorial times 5 factorial ways. And that will give me, as you can use your calculator to calculate this value, and you'll get 240. Next question is Mary and 5 other passengers seated to be in a certain row is seats allocated random. What is the probability? Now it comes to probability now, right? So to be very careful, read the question very carefully. Whether I should use a number of methods, whether I conclude the answer as a number or as a probability. So that is very important. Numbers at the end of the row. So here, what will happen here is, let me write down this value. This is my 720 is my total sample space. Now I can wipe the remaining. So here, what is happening? There are 6 seats, and Mary will sit at the end of the row. So we do not know which end it is, right? So that is a crucial here now. Right? It can either be on the left, right? Mary can either be on the left or Mary can either be on the right. We do not know which end it is. There were 2 possibilities, therefore 2 times. And the remaining can be arranged they can be in 5, right? 5 factorial ways. So remaining can be in 5 factorial ways. So probability of Mary at end at the end of the row is equal to, so 2 times 5 factorial divided by 6 factorial. So I get my answer as 1/3. So that's the answer. So here the key here is end of the row, right? End of the row. So end of the row means there are 2 possibilities. It can be on the left hand side or on the right hand side at the end of the row. So probability Mary at the end of the row is 2 times 5 factorial, remaining of the 5, the remaining 5 people. Yes. So that's my answer, 1/3. Again, it's a typical exam questions. For two events A and B, it is given the probability of A is equal to 0, 2, probability of B is 0, 3, probability of A and B is equal to 0, 126. Are the events A and B independent? Justify your answers. Justify your calculations. So probability, what if first probability of A and B is given to be 0, 126. Right, then what I do here is I calculate probability of A times we have to find whether they are independent. Therefore I'll separately find A and B, and then probability of A times probability of B. Right, so I find them separately and see if they are equal. So probability of A times probability of B will 0, 2 times 0, 63. So I use my calculator and find them, and find that it is going to be 0, 126. Therefore they are equal. Therefore hence we can see probability of A and B is equal to probability of A times probability of B. Therefore A and B are independent. Therefore A and B are independent. So don't simply write independent. You have to justify your answer using your calculations. So don't first write this step at the beginning. Or you can say to show, if you are writing was right, very specific, to show that they are equal. Right? So to prove that they are equal. So better don't write this. That's my opinion. First write probability of A and B as 0, 126, and then you calculate the product of these separately, right? And see if they are equal. If they are equal, you write them are equal, and then conclude they are independent. And if they are not equal, you write specifically they are not equal, and then conclude they are not independent. So such questions comes in your probability question. So here actually some questions are very, if you understand the concept, is very straightforward. You save time also here. The next question. Word decimal are randomly arranged in a new word, also consisting of 7 letters. So I have here, how many letters I have? DECIMAL. So 7 letters, and none of them are repeating. Good. Then letters, I have to make another 7-letter word, right? I have to make another 7-letter word where repetitions are allowed, which is good, right? So repetitions are allowed. So it is 10, 11, 2, 1. Repetitions are also number of different arrangements, where that means I can use here 7 to the power of 7-letter word, therefore 7 to the power of 7. Yes, and I can use my calculator to find the value here. Is going to be 823,543. Then 11,22 letters may not be repeated. So number of different arrangements where letters are not repeating. So number of different arrangements will be 7 factorial ways. And you can use your calculator to calculate the 7 factorial, and I get as 5040. There's no probability here, so all is a different arrangement counting principle only. Next is interesting question. The arrangements must start with a vowel and end in a constant, and a repetition is not allowed. So I have a 7-letter word here. 1, 2, 3, 4, 5, 6, and 7. And I must start with the vowel. So how many vowels are here? So you must know English language. Yeah? So vowels are A, E, I, O, U. So there are 3 vowels you can see is A, E, I, O, U. So there's no O, there's no U. The other 3 are here. The first letter has to be A, E, I, O, U. Right? Must start with the vowel. So for A, E, I, there are 3 choices I have. Right? And then constant, other must be constant, it cannot end with a vowel again. Therefore options is D, C and L. Therefore, I have three options. Like here again, I have three options at the first one, and the three options at the three choices, not options. Three choices I have for the first letter, and I have three choices for the last letter. So repetition is not allowed. Therefore, the restrictions will be there. Number of choices is restricted now. So the two of them are already gone. The two of them, one here and one here, are already gone. Therefore, I am restricted now to 5. For 5, 4, 3, 2, 1. So number of possible arrangements with starting with a vowel and ending with a constant is how much it is? It is three choices. 3 times 5 factorial times 3. That is my answer, and you can use your calculator to so it is going to be 1080. So it is an interesting question here, starting with a vowel and ending with the constant. There were three choices at the beginning, at the start, and three choices at the end. It's not repeating, and no repetition allowed. Therefore, my restrictions. Therefore, there will be a restriction on the number of choices for the remaining letters. That is why I have this 5 factorial. I will have a separate video in explaining this particular concept, this particular answer. Next question. Given that A and B are independent events, determine the values of X and Y. Is given, information is given, probability of B only, probability of A and B is given 0,2, probability, we have to find probability of A only, that is X, and probability of not A or B, which is equal to Y. First, let's understand this probability of A and B, right? So probability of A and probability of B, and this is the sample space. This is A and this is B. So probability of B only, that is this part, is 0,3. This is B only part, and this part here is 0,2, A and B. Therefore, probability of B, I have probability of B is equal to 0,5. Right? So some questions we can do without drawing a Venn diagram. I draw this Venn diagram because to get a better understanding. There's no need necessary for us to draw the Venn diagram, but this will help us to understand the whole picture. That's why I did draw the Venn diagram. So probability of A and B, is given to be 0,2. Now read the question very carefully. A and B are independent events. Therefore, a probability of A and B I can write as probability of A times probability of B. That is 0,2 is equal to probability of A times 0,5, because probability of B is 0,5. So I can find the probability of A. And that is probability of A will give me 0,2 divided by 0,5, and that will give me 0,4. So probability, I use my calculator, or you can do it without calculator if you are very good in calculations. So I got probability of A is equal to 0,4. So probability of 0,4 means this is my probability of A, this entire thing here. Therefore, what is probability of A only? Right, A only, that means this part. This is my 0,2. So the entire part will become probability of A, and I remove the probability of A and B, that will give me A only. Or that is my answer is 0,2, or 0,4 minus 0,2. So that is my answer for X. Therefore, X is equal to 0,2. Now next question here is to calculate the value of Y. That is what the X and B have calculated the value of X. Now it's called the question is to calculate the value of Y. Not A or B. Not A or B means outside. This is not, right? Not A or B. Right? Not A or B. So not A or B is outside this probably, right? Not A or B. In other words, it is 1 minus probability of A or B. Right. So what is my probability of A or B? You can use the either definition, the addition rule, or you can calculate directly from this here, which is equal to 1 minus which how much I get it? 0,7. Right. You can use addition rule, probability of A plus probability of B minus probability of A and B. Or you can use the Venn diagram here, straight away it will be 0,7, and therefore my probability of not A or B is 0,3. Therefore Y is equal to 0,3. So that is my answer here. There's no necessary for us to draw the Venn diagram, but when I draw the Venn diagram, I'm able to solve. I get a bigger picture of what I'm talking about. Next question here is six players. What's happened? 6 players of volleyball team stand at random positions in a row before the game begins. X and Y are 2 players in this team. Determine the probability that X and Y will not stand next to each other. So here there are 6 players, right? And I have 6 players. X and Y are not stand to each other. So probability of X and Y together, right? What I do here, X and Y together is minus probability and not X and Y together. That is what I do here. So to find the probability of not X and Y, so not X and Y, I must write as 1 minus probability of X and Y. So what I do here, first I find the value of probability of X and Y together, and then I can find it not together. That's what I'm going to do here. So this is the rule here, probability of A complement is equal to 1 minus probability of A. I'm again applying and that symbol concept or important concept in probability. So let's start finding the probability of X and Y together. So what I do here is X and Y are together, and there are other 4 players, right? So that total will give me 6 players. Therefore, if I take X and Y together, X and Y has to be together. X and Y has to be together. Therefore, in total, I can take them as a one of them. Therefore, I have 5 factorial ways, and therefore, what I find 5 factorial ways, and X and Y can be itself be arranged in 2 factorial ways. So, probability of X and Y together, X and Y together will be 2 factorial times 5 factorial divided by all of them together. Right, so sample space is 6 factorial. So probability, sample space, I forgot to write about sample space. So sample space is my 6 factorial because there are 6 players. So 2 factorial times 5 factorial divided by 6 factorial. I remember one of them in one of the previous years asked why we don't use 6 to the power of 6. Remember the 6 players, they cannot be repeating, right? It's very straightforward, simple logic, right? So let's come back to this question. Probability of X and Y is equal to 2 factorial times 5 factorial divided by 6 factorial. Now the question is to find not together. So not X and Y together, not X and Y together will be 1 minus whatever value I find here, that is 2 factorial times 5 factorial divided by 6 factorial. So it is exactly how much? 1 minus 1 over 3, and that is giving me 2 over 3. So probability that they are not together is 2 over 3. This is going to be my last question here. 12.3. Determine how many 4-digit numbers can be formed from 10 digits 0 to 9. The examiner is generous, is already telling us there are 10 digits from 0 to 9. I have to make 4 digits that are repeating, right? So number of 4-digit numbers. So number of 4-digit numbers, how many I can have here? 4 to the power of 4. Sorry, there are 10 digits, so 10 to the power of 4, right? Not 4 to the power of 4. Because there are 10 possible choices I have. I have 10 choices for each digit, therefore 10 to the power of 4. Then next is, if digits are not repeating, right? This is for repeating, and this is for 4 digits non-repeating. They are not repeating. That is equal. So for it is 10 times 9. There will be restrictions in the subsequent selection of digits. So first digit has have 10 choices, second digit restriction because non-repeating. I can use my calculator to evaluate this value. So it gives me 5040. Next is 12,33. What's the question? The last digit must be 0 and a repetition of digits is allowed. So last digit is 0. That means it's not is a number is not a with last 0, right? With end 0. I have last 0. Therefore, I have no choice for the last one. I don't have a choice for the last one. So for last one is only one choice, that is number, which is 0. Therefore it is 10. I have 10 choices here, 10 choices here, 10 choices here. Therefore number of digits that I can form with the last digit 0 is 10 to the power of 3 times 1. Therefore my answer is 10 cube, and my 10 cube is how much? 1000. That's my answer. So rather probability is rather a simple topic, but provided you understand the concepts very, very clearly, just simple applications of the concept. Read the question very carefully before you start attending the questions in probability. A little bit of language is required. Understand the language and try to translate the language into mathematical language. And understand the probability concept of the probability. Then it will help you to nail the questions.